Welcome to the technical evolution of Credixa. We are the team, TheDevCrew, presenting our final phase 3 extended prototype. The core objective of this project is to validate the concept of an autonomous ML-driven buy now pay later lending platform specifically tailored for the education sector. We aim to solve the education affordability gap. Currently, traditional educational loans rely on physical document handling and manual underwriting, resulting in a turnaround time of 15 to 20 days. Furthermore, banks routinely reject thin file students who lack a traditional CIBIL score. Credixa validates a modern alternative. By utilizing machine learning to analyze alternative financial data, we can originate loans for students algorithmically, asynchronously, and instantly. To understand our architectural decisions, let's trace the exact data flow of a loan application. Our architecture consists of 4 decoupled layers: the front end, the back end gateway, storage, and the AI risk engine. The flow begins in the React front end, where a student submits their KYC credentials and uploads their bank statement. This requires HIST, our Node.js Express gateway, which serves as the central orchestrator. First, the auth service hashes the password, generates a JWT token, and inserts the user into the user's PostgreSQL table. Next, the document handler logs the file references in the documents table and streams a multi-part form data payload directly to our isolated Python AI risk engine. Inside the AI risk engine, we execute our ETL pipeline. The PDF Plumber library extracts raw unstructured text from the PDF to create a numerical feature array. This array is fed into our pre-trained scikit-learn random forest model, which calculates a probability of success and returns a risk payload containing the Omni score and an algorithmic decision. Finally, the loan service receives this payload, inserts the score into the risk scores table, and updates the loan stable status to approved or under review by separating the IO-heavy Node gateway from the compute-intensive Python engine. We ensure the system never bottlenecks. At this point, we must address a critical divergence between our Phase 1 design and our Phase 3 implementation. Originally, we planned to ingest financial data securely using the Sahmati account aggregator ecosystem and verify identities using IndiaStack's API Setu. However, these are strictly planned but not implemented in this prototype. The reason is a strict regulatory constraint. Accessing live production environments for IndiaStack and account aggregators requires FIU and NBFC licenses. These are legally unavailable for academic projects. To keep the project technically viable without violating RBI access constraints, we engineered the proprietary Python PDF parsing engine to ingest manually uploaded bank statements. To ensure the integrity of this logic, we designed 3 rigorous test scenarios. Scenario 1. Submitting a fabricated bank statement flooded with overdraft and NSF fee keywords alongside a low average balance. Scenario 2. A student applies with valid PDFs. The Python model evaluates the file, outputting an Omni score, and the admin approves the loan. Scenario 3. Concurrent UI state validation. Simulating a successful UPI repayment API call while monitoring the student UI. Let's test these scenarios. Now, let's deep dive into our application. First, register as institution. Now login. Now you can see the Credixa admin console, which is admin dashboard for institutions. Now register as a student. Okay, registration successful. Now login. Let's complete the KYC profile. Upload the required documents. Let's fill up the co-applicant profile. Upload ITR document. Now you can see the student dashboard. When you click the view profile, you can see the student's detail. And when you click the checklist, you can see all the checklist document that we required. Now let's apply for loan. Click next. Let's fill up the final step. So for the student bank statement, I upload the student 1, and for parent I am uploading student 2 for checking the high risk. Let's click on run. Okay, the application is under review. Let's go to the admin dashboard. Now you can see AI Omni score is 48, which is very high. Let's reject the loan. You can see the profile as well. Okay, loan is rejected. You can see the loan is rejected. Now let's apply for the new loan. Click next, fill up the final step. Now this time I am going to take parent 1 for low risk. So let's run AI assessment, application under preview. Now you can see the loan is applied. Refresh the page. Now you can see low risk. Now you can see 864. Now approve the loan. Let's go to student dashboard, refresh it. Now here you can see the active loan status. Let's make payment. Now you can see the loan progression and payment history. Now let's go to admin dashboard. Now you can see repayment progress. Let's pay all the loan. Now you can see the loan is closed. Okay, so here you can see the loan is closed as well. You can apply loan for the next semester. While Credixa is currently running as a local prototype and is not yet deployed to the cloud, our foundational architecture was intentionally engineered for future scale. Because we have already containerized our microservices using Docker, transitioning this system to a live production environment will be seamless. Looking ahead, our deployment roadmap involves utilizing Kubernetes. This will allow us to auto-scale the Python AI risk engine independently of the Node.js Express API to prevent bottlenecks during high-traffic college admission seasons. Furthermore, our third normal form PostgreSQL schema physically prevents data redundancy, guaranteeing that complex queries will remain highly performant as our latest grows. In conclusion, Credixa is more than just a theoretical concept. It is a dev-ready, closed-loop educational middleware. By replacing a 15-day manual underwriting process with a sub-200 millisecond algorithmic decision engine, we have successfully proven that financial utility can be securely provided to thin file students. We have bridged full-stack engineering with data science to deliver a highly feasible architecture, backed by verifiable test cases and a robust programmatic system mitigation strategy. Thank you.